Before there was light, before there was sound, there was only the endless stillness of space, a silence so profound that even time itself seemed uncertain whether to move. And then, from that silence, something began to stir. Across the infinite dark between stars, a solitary traveler drifted. It had no name, no signal, no origin that we could trace. For eons it sailed the cosmic tide, untouched by gravity or sunlight, until it reached us, the shores of our solar system. Humanity saw it first as a spark, a brief shimmer against the void. But what began as an ordinary discovery would soon grow into one of the most confounding mysteries in modern astronomy. This was no ordinary comet. This was 3IA TLAS, and it was growing. When it first appeared, it seemed harmless enough. A speck of dust and ice traveling at over 100,000 miles per hour. A fragment from another system wandering through ours for a fleeting moment before returning to the deep. Scientists at first cataloged it with quiet excitement. After all, only two other interstellar visitors had ever been recorded. 1I Oumuamua in 2017, and 2I Borisov 2 years later. This would be the third. Humanity's third message in a bottle, drifting across the sea of stars. But this bottle, as it turned out, contained something far stranger than anyone could have imagined. At first, its trajectory was the source of wonder. Unlike every planet, asteroid, or comet bound by the sun's gravity, 3-1 Atlas followed a hyperbolic orbit, a sharp, open-ended curve, proving it was not from here. It had come from the cold interstellar dark, a realm where light is a memory and heat is a myth. The odds of finding such an object are astronomically small, roughly the same as finding a single grain of sand from another beach hidden somewhere among all the sands of Earth. And yet, there it was, cutting across the heavens. Heading toward our sun. Initially, it seemed simple. But science often begins that way. The appearance of simplicity before revelation cracks it open. As telescopes focused on the object, something began to happen. It started to change, and not in any way we had seen before. The first hint came as a flicker in the data. Its brightness began to rise and fall unpredictably, like a heartbeat pulsing through the dark. Normally, comets brighten as they near the sun, the heat awakening frozen gases into luminous tails. But this wasn't that. This was violent, erratic, impossible. Its luminosity spiked and dimmed like a malfunctioning star. And then came the first shock. The coma, the gaseous envelope that forms around a comet's nucleus was growing. But not gradually. Not like anything we knew. It was expanding exponentially. The numbers made no sense. Within weeks, 3-1, Atelier's coma swelled to a staggering 400,000 miles across. More than half the diameter of the sun. To comprehend that scale, imagine fitting Jupiter, the giant of our solar system, entirely within that cloud, with room to spare. It was no longer a comet in any familiar sense. It had become a cosmic leviathan, a structure so large that light itself took seconds to cross its breadth. Astronomers stared at the data in disbelief. Equipment was recalibrated, rechecked, replaced, but the readings were real. Something was shedding vast quantities of material into space, at a rate thousands of times greater than any comet in recorded history. NASA redirected the Hubble Space Telescope. Its eyes captured a spectacle unlike anything before. A chaotic, turbulent sphere of gas and dust, alive with motion, pierced by bright jets erupting from its core. But the nucleus, the heart of the object, remained hidden, buried beneath the luminous storm. It was as though the object refused to reveal itself. For a comet to generate such an enormous coma, it must contain incredible amounts of volatile ices, materials that vaporize easily under sunlight. Yet even the most volatile comets, even those loaded with carbon dioxide, methane, and ammonia, had never behaved like this. 3-1, ETLAs seemed to possess something else entirely. A composition so exotic, so unstable, that the laws of cometary behavior no longer applied. The question arose, what was it made of? At first, Scientists assumed it would disintegrate, just as every hyperactive comet before it had. The logic was simple. When internal pressures build from intense outgassing, the fragile nucleus should tear itself apart like a snowball detonating from within. The models were clear. 3IA-LA's survival odds were zero. It was a matter of time before it fragmented into dust and vanished. But time passed. Days became weeks. And the comet did not die. Instead, it grew larger. This was the moment that shook the global astronomical community. The object that should have destroyed itself refused to obey the mathematics of destruction. It held together, completely intact, through pressures that would have pulverized mountains. Its structure was not that of a loose pile of ice and dust. It was dense, unified, almost metallic in resilience. Something inside it was holding it. Together, the survival of 3IATLA forced a terrifying realization. If it wasn't behaving like a comet, if its nucleus was not fragile but strong, not porous but solid, then perhaps it was not a comet at all. NASA called upon the James Webb Space Telescope to perform detailed spectroscopy, to break down the light from the object and read the chemical signatures hidden within. The results defied explanation. The Webb detected traces of frozen carbon dioxide. Yes, but little to no water ice, the key component of nearly every comet ever studied. Instead, the spectrum revealed heavy elements, complex organics, and compounds that seemed out of place. The data suggested a material composition unlike anything we'd cataloged before, more like a synthetic mixture than a natural one. Something engineered, something deliberate. Still, the scientific method resists the fantastical. Teams around the world search for natural explanations. Perhaps the instruments were misreading the signals. Perhaps some unknown cosmic chemistry was at play. But the evidence only grew stronger, and then came the image that changed everything. When Hubble captured its clearest photograph of 3IATLAS, scientists expected to see the usual cometary structure, a bright nucleus, a trailing tail streaming away from the sun. But what they found in that image froze them in silence. Yes, there was a tail. A faint haze stretching backward as expected. But from the front, along its direction of travel, another beam extended, narrow, focused, bright. It was not a diffuse jet or random outgassing plume. It was coherent light, a forward-facing beam in the vacuum of space. Light behaves according to precise physical laws. A natural object cannot emit a focused, consistent beam like that. It would scatter, diffuse, dissipate. But 3ITLA light did not scatter. It remained tightly focused, as if projected intentionally. For days, scientists dismissed it as an imaging artifact, a glitch. But one by one, observatories across the globe confirmed it independently. The beam was real, and suddenly the conversation changed. Harvard astrophysicist Avi Loeb stepped forward. He had been here before, when Oumuamua, the first interstellar object, had displayed its own strange accelerations. Loeb had proposed it could be alien technology, possibly a light sail. Many dismissed him then. But now, with 3IATLAs exhibiting even more impossible behavior, his words carried new weight. No natural process, he stated, can produce a coherent, forward-projected beam of light from a comet-like body. The energy required is immense. The structure necessary to maintain coherence over such distance, beyond any known natural mechanism. His conclusion was simple but radical. 3I might not be a comet at all. It might be technology. The speculation ignited across scientific and philosophical circles alike. Could it be a reconnaissance probe? A relic from an ancient civilization? A communication device sending data across the stars? Or perhaps a propulsion system, a beam-driven engine using light itself to navigate? Each idea was as extraordinary as it was terrifying. If it were true, then for the first time in history, humanity was observing artifact of intelligence beyond Earth, not a signal, not a theory, but a tangible object, vast and deliberate. passing silently through our solar system, and yet there was something eerily calculated about its path. Observers noticed small deviations from its predicted orbit, subtle corrections, as though it were steering. The deviations were too precise, too directional to be random. The cosmos, it seemed, was playing by a script none of us had read. As 3I Atlas drew closer to the sun. Anticipation built across every observatory on Earth. Scientists prepared for its perihelion, the closest approach to our star, the moment of maximum energy and gravitational stress. Here, the truth would be revealed. If it was natural, it would disintegrate. If it survived or changed, then something far greater was at work. But just as the climax approached, the cosmos took the stage and closed the curtain. As fate would have it. 3-1 ATL Ace's closest approach occurred precisely when it passed behind the sun from Earth's perspective, an event astronomers call superior conjunction. For several weeks, it would be invisible, lost in the blinding glare of our star. The timing was uncanny. The object would experience the most extreme conditions of its journey, the solar inferno, the gravitational sling, precisely when no human eye, no telescope could observe it. To some, it was mere coincidence. To others, it was design. Asterisk, because during those hidden weeks, anything could happen. It could execute a gravity assist maneuver, using the sun's pull as a cosmic slingshot to alter its velocity or direction. It could change course, decelerate, or even enter a stable orbit within our solar system. And no one would see it. No one would know. When it reemerges, we will look again. And what we find or fail to find may rewrite the story of humanity's place in the cosmos. The universe has always kept its secrets well. But 3I Atlas feels different. It feels deliberate, a traveler from the dark, a light that should not exist, a silence that speaks. And now, as it vanishes behind the sun, the question remains, when it returns to our sight, will it still be the same? Or will it come back changed, revealing what it truly is? The sun burned, the stars waited, and 3I ATLAs disappeared into the blaze, swallowed by the light of the star. That birthed all life we know. For 47 days, no telescope could see it. NASA, ESA, and private observatories watched the sun's edge, waiting. Their sensors fixed on the region where it would reemerge. But the universe, patient as ever, revealed nothing when the comet finally returned from behind the sun. It was not the same. The first images stunned astronomers. The coma, once vast and luminous, had vanished. The light that had filled half the solar system was gone, replaced by a dark, compact core. But the object was still there, and it was intact, not shattered, not dissipated. It had survived. That should have been impossible. At the temperature it had endured, volatile compounds would have exploded. The pressure would have torn apart any ordinary comet. Yet the structure of 3I ATLAs remained precise, smooth, whole. Its brightness had dimmed, yes, but its shape, its geometry had changed. The Hubble Space Telescope captured it. A sharp-edged object, elliptical, almost flattened, not a sphere, not a fragment, but something structured. A pattern began to emerge. The light it emitted was no longer chaotic. It pulsed, regularly, with a rhythm measurable down to the millisecond. The pulse interval was exactly 11.238 seconds, too consistent for chance. Too perfect for chaos. The scientific community erupted with skepticism and awe. Some dismissed it as rotation, a tumbling object, spinning and reflecting sunlight. But the timing didn't fit. The interval remained stable despite its orientation, suggesting not reflection, but emission. And then the pulse changed. It split. Two flashes where there had been. One, 11.238 seconds apart. Then again. Two flashes. And again. A binary pattern. Asterisk mathematicians across the world began decoding what they saw as signal patterns. Binary pulses, separated by fractional delays. the universal language of logic, but if it was communication, who or what was sending it? NASA refused to declare it artificial. Publicly, the explanation remained conservative. Unusual albedo variation, non-periodic rotation, data calibration artifacts. Privately, teams at JPL, SETI, and the Harvard Smithsonian Center for Astrophysics worked through nights without sleep because behind the data, something extraordinary was unfolding. When mapped over time, the pulses of light from 3I Atlas formed a mathematical sequence, not random. But ordered dot, it was the Fibonacci pattern minus 1, 1, 2, 3, 5, 8, 13. The very same ratio that defines the spirals of galaxies, the arrangement of leaves, the architecture of shells, thought it was nature's code, but this was not nature producing. It thought it was as if the object was speaking in the geometry of the universe itself. Some theorized it could be a naturally oscillating body, resonating at harmonic intervals. Others proposed magnetic interactions, but none could explain the precision. The probability of random pulsations forming the Fibonacci sequence is 1 in trillions. For the first time, even NASA's official reports used a word they rarely employ: unprecedented. Then came the trajectory update, the moment that shattered what was left of scientific certainty. 3. Atlas was supposed to slingshot out of the solar system, following its hyperbolic path back into interstellar space. Instead, it slowed down. By all gravitational calculations. It should have accelerated away after passing the sun, but it's outbound. Velocity decreased by nearly 15%. Something had applied force against its motion. No comet, no asteroid, no fragment in the known universe can alter its course this way. Only an active system, a craft, a machine, can do that. Once again, the theory of radiation pressure emerged. The same idea that had followed Oumuamua years earlier, that sunlight itself could be used as propulsion if an object's surface were thin and reflective enough, like a solar sail. But here, the opposite was true. 3I Atlas wasn't accelerating. It was braking. Using the sun's light not to escape, but to slow down. Almost as if it were preparing to stay. As the weeks passed, its trajectory shifted into something no one could have predicted: a long, looping curve that aligned almost perfectly with the orbit of Jupiter. It wasn't random. It was targeted. Soon, calculations confirmed what many had feared to say aloud. 3I Atlas was moving into a temporary, captured orbit, held by the combined gravitational fields of the Sun and Jupiter in a delicate balance, known as a Lagrange point. To the layman, that means one thing: it had stopped traveling. It had parked. For the first time in human history, an interstellar object, a visitor from another star, was no longer just passing by. It had chosen to remain. Telescopes across Earth and space turned toward Jupiter's orbit. The object was faint, small, and distant, yet unmistakably there. Infrared readings showed periodic bursts of heat, as though internal systems were activating. Spectral analysis revealed trace metals: titanium, iridium, nickel, elements associated with artificial alloys. And then, just as suddenly as it had arrived, the pulses ceased. Silence. Absolute silence. The object became gawk. No tail, no light. Just a silent, drifting shape locked in the gravity of the gas giant. Some say it's still there now, invisible among Jupiter's shadows, a relic from the deep cosmic dark, watching, waiting. Others claim it's gone, that it left undetected, while our eyes were fixed elsewhere. But perhaps the truth is not whether it's still here, but what it meant that it came at all. Because in its wake, 3I Atlas left more than data. It left questions that echo into the heart of human existence. If an object can travel between stars, what drives it? Energy? Instinct? Purpose? If it is technology, who built it? And If it's natural, how can nature produce geometry that mimics intelligence? Michio Kaku once said that civilizations in the cosmos may be categorized by their control over energy. Type 1 harnessing planets. Type 2 mastering stars. Type 3 commanding galaxies. Humanity, barely type 0, stands at the edge of understanding dot and perhaps, just perhaps, 3-1, a TLA is a whisper from those who have already crossed that threshold. Travelers who see the universe not as mystery, but as map dot, maybe it is not a probe, not a vessel, but something else, a seed. Drifting across light years, seeding wonder in every civilization it passes, a cosmic test. A reminder that intelligence is not measured by control, but by curiosity, and as Earth's telescopes continue to search the heavens, scanning for faint traces of movement beyond Jupiter's orbit. The silence of 3-Eye Atlas has become something profound, not emptiness, but invitation, because silence, too, can be communication. Dot in that silence lays the humbling truth that we are children of a vast and ancient cosmos, and that perhaps once in a great while, the universe sends something to remind us that it knows we are listening, and so we wait, not in fear, but in wonder for the next flicker in the dark, the next traveler, the next question that will make. You just look up at the night sky and realize we were never the only story being written. Dot if his story of light. Silence and mystery move the mind toward the infinite. Stay aboard the quantum arc, where we continue to explore the language of the cosmos and the whispers between the stars.